So, before we get into it, there are two different types of events that we have to talk about. I mentioned I mentioned independent events to you before. So let's start with those. Independent events. This is when, like rolling the die or the dice, right? When I roll it the first time, I got a 6. Okay, when I pick it up and roll it again, the outcome of this event has nothing to do with what I just rolled, right? I could roll a 6 again. This time I rolled a 4. They have nothing to do with each other. They're completely separate, okay? So, the outcome of the event is not affected by a previous event. So some examples of independent events, we have rolling a die. I could flip a coin, right? If I flip a coin, then I flip it again, the result of the last one has nothing to do with the next one. Yep. It'll be really dark. You can try it. I bet you it's going to be very, very, very dark.
We did it yesterday.
Can you see?
Yeah. It feels so nice.
All right. So, let's say, we'll add to this list later of other examples. Let's say I wanted to find the probability of rolling a 3 on my die and then rolling a 5. Since the two have nothing to do with each other, in order to find the probability of that happening, I always like to imagine I'm playing a game. I'm going to win this game if I roll a 3 and then I roll a 5. Okay, I have to do that, roll a 3, then roll a 5. I want to think, okay, well, how likely is it that I'm going to win this game? First of all, is it even possible? Could I roll a 3 and then roll a 5? Of course I could, right? How likely is it to happen, though? Well, here's how we figure it out. So the probability of event A, then B. I'm going to give you the general formula and then we'll put it in. Oh, why did I make that so big? I don't know. Ignore that. You're just going to take the probability of A happening and you just multiply it by the probability of B. That's it. It's just that easy. So you just take the probability of the first event times it by the second event. So I said rolling a 3, then a 5. So if I wanted to find the probability of both of these things happening, I just find the probability of me rolling a 3, which would be what? 1 out of 6. And I'm going to multiply it by the probability of me rolling a 5, which is 1 out of 6. So the answer would be, what is 1/6 times 1/6? What'd you say? You want to multiply. 1 over 36. So I have a 1 out of 36 shot of rolling a 3 and then a 5. So do you think I'm going to win? Probably not. But let's see. Oh! I already lost. Got the 3. 6. Shoot. Oh well, didn't win.
Congratulations.
Okay, so what would the probability of me rolling
A 6 and a half.
okay. You want a 6 then a 1. Don't you already know the answer? What's it gotta be? 1 out of 36. Rolling any two numbers, it's gonna be a 1 out of 36. What if I asked you about rolling a 2 and then another 2? It's still 1 out of 36. Because just because I rolled a 2 the first time doesn't have anything to do with me rolling a 2 the second time. Okay? So, if I'm going to do any two numbers, it's going to be 1 out of 36. What if I wanted probability of, let's change it up now, rolling an even, then a 5. So on the first roll, all I have to do is get an even number. Then I need to get a 5. Jed, you got it?
3 out of 36.
Tell me how you got there. What's the probability of rolling an even?
3 out of 6.
3 out of 6. Does everybody agree? Because you've got 3 evens out of 6 total, yes. And then rolling a 5 would be 1 out of 6. So if you multiply straight across, you said 3 out of 36? Which is really 1/12. Yes. So,
Quick part interruption. At this time, seniors on the 3rd floor, rooms 3102 to 3117, and the 4th floor, please report to the auditorium at this time. Thank you.
okay. So there's even and then a 5. One more and then we'll try something different. What if I wanted you to roll roll what was I gonna do now? Roll a number less than 5 and then an odd. Any number less than 5 and then rolling an odd. Oh, and then one more. You have an answer? For this one right here, rolling a number less than 5, then okay. So what's the probability of rolling a number less than 5? 4 out of 6, right? Less than 5, so 1, 2, 3, and 4. 4, oh,
4 out of 6.
thank you. And then rolling an odd. What's the probability of rolling odd? 3 out of 6. So when you multiply this together, what'd you get? 12 over 36, which is really 1/3. Yes. Okay, last one. Probability of not rolling a 2. What is that, Jed?
25 over.
Oh, I'm not there yet. Start with the not rolling a 2.
So that's 5 out of 6.
Yeah, wouldn't that be 5 out of 6? Then all I have to do is roll a 1, and that would be 1 out of 6. So my answer, did you say 5 out of 36?
Oh, I thought it was not rolling a 1.
Oh, sorry, yeah. I want you to not roll a 2 and then actually roll a 1. Okay, does that make sense? in the video, did I talk about a sample space?
Yes.
Oh, good. Passed me.
And the wiggle.
And I did what?
The Wiggles.
I did? Oh my gosh, what did I say about them?
How one of them, like, it was a class with Mrs. Brady.
Yes. Oh yeah, one of them got married. Yeah. That's the thing with the videos is that I never go back and edit them. So I have no idea. Like by the end of the day, I have no idea what I said on these things. So who knows what's out there? That's fine. Okay. So you already know about a sample space. Let's try a dependent event, shall we? Because remember I told you there's two types. There's these independent events. And then there's one that's a little bit more complicated called the dependent events. But these are fun. So these are ones where the outcome does matter. Okay? So, a great example is if I ask you to pick a card, any card from a deck of cards, and then I asked someone, so you pick a card, right? But then I go to the next person and I say, okay, now you pick a card. Well, their probability of selecting a card now is different, right? Because there's one less card in the deck now because someone else already picked one. You follow me? You follow me? Okay. So, picking cards, if you don't put them back, it's going to affect everybody else's down the line. Or you could even think, I don't know, maybe you do your laundry once a week. So if you have, 10 shirts to choose from, and you're only going to wear each shirt once, right? At the beginning of the week, when everything's clean, you have 10 shirts to choose from. So you're going to pick one. But then the next day, now you only have 9 shirts to choose from. The next day, now you only have 8, right? That's going to keep going, unless you're just... But you can visualize.
The event changes the number of outcomes for the next event.
Exactly. So, outcome of the event is affected by a previous event. So, for example, selecting a card and not returning it and selecting another. Another example, your shirts worn throughout the week. Let's say you were trick-or-treating at some house and they just had a big bowl of all sorts of candy mixed in together. That first kid that showed up at that house had the best selection, right? And then every kid after that is going to have a different scenario for when they go to select. Maybe, I don't know, maybe all the stickers got taken by the first 10 kids. And now that poor 11th kid, they have to choose between Three Musketeers and Milky Way. Blech. Anyway, I'll throw that on there. I like that one. Trick or treating. So, how do you figure out the probability of dependent events? Well, it's actually the same way. You just have to consider your new scenario. So, the probability of A, then B of dependent events, you're still going to do the probability of A, then probability of B. You just have to consider the scenario. So, for example, let's do the probability of, you know what, let's do, remember on the very first day we were talking about, oh no, it was in the video, wasn't it, mathematics?
Yes.
I scanned through it real quick and I saw this part. So if I take the letters of the words mathematics, put them on index cards, and I'm going to pick them at random. So if I want to figure out the probability of selecting M, then T without replacing. So here's how we do this. For selecting an M, I'm going to do it just like I always have been. What's the probability of me selecting an M? 2 out of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 2 out of 11. However, when I go to pick the second card, how many T's are there going to be if I picked an M the first time? And then I go back in, how many T's are there? There's still 2, but how many total cards are there now?
You only picked one.
You only picked 1 card so far. 10. There's 10 cards left. I picked 1 card the first time. I had 2 chances for it to be an M, but I only picked 1 card out. Bless you. So, I got an M. Now I'm going in to pick my second card and I want it to be a T. There's still 2 T's in there because I only selected an M so far. But there's only 10 cards left. You with me so far? And now, to find my answer, I'm just going to multiply them. I get 4 over 110, which reduces to be 2 out of 55. You guys can reduce before you multiply also. If you want to reduce 2/10 to 1/5. Make your life a little bit easier if you wanted. It's up to you. Does that make sense? Okay, you try this one. Let's select a vowel, then an H without replacing. Yeah. It would depend, but in this case, we don't have to worry about it. You remember which are the vowels, right? What are my vowels? A, E, I, O, U. Yes. Sometimes Y, but it doesn't matter this time, so we don't worry about it. So how many total vowels do I have to choose from? 1, 2, 3, 4. Right? So when I go to pull out that first card, there's 4 chances for me to get a vowel out of 11. So I just did it. I pulled out a vowel. I have a vowel in my hand. Now I'm going to go back in and I'm going to try and pick an H. How many opportunities do I have to pick an H? There's only 1 H in the whole thing, and there's only 10 cards. Because I have the 11th in my hand already. I already picked it. So now there's only 1 out of 10. So my answer is 4 out of 110 again, so it just so happens to be 2 out of 55. Oh, weird. That will not always be the case. Let's change it up. Okay, you ready for this one? I'm going to try and stump you. What'd you say? There's no way? I want you to select an M, then another M without replacing. We're playing some weird game where you will win if you pick two M's in a row. Figure out the probability that that's gonna happen. I will give you a hint. The answer is not 4 over 121.
Betty bet.
So if you thought it was 4 out of 121, I caught you. Oh wait, maybe you think it's 4 out of... It is not 2 out of 55 either. I don't think. Okay. Who thinks they have it? What's your answer? 1 out of 55. Nayara, you agree? Anybody else have an answer? 1 out of 55? Yep, what's yours? 1 out of 52. Yep.
I got 2 out of 9.
2 out of 99. Let's see. Okay. Imagine this. I have mathematics. They're on the cards. I'm going to pick one. What's the probability? I'm going to select an M that first time. 2 out of 11. Can we all agree there? 2 out of 11? But remember what just happened. I just picked out an M. I have it in my hand. I'm going to pick a second card. I'm trying to get an M again. When I go to pick it the second time, how many M's are left? There's only 1 M left because I'm holding on to the other one. So I only have 1 M that's even there. And how many total cards am I picking out of? 10. So those should be your 2 fractions this time. Right? Because I had 1 fewer. If I'm picking an M and then another M, there's not going to be 2 M's in there the second time. Because I already picked one out. So that turns into 1, yeah, 2 out of 110, which reduces to be 1 out of 55. Tricky. So you try it with this one. Let's see if I can get... I want you to do a vowel, then another vowel. No replacing. We got answers? What's the probability of selecting a vowel the first time? Haley?
4 out of 11.
You got it. 4 out of 11, just like it was before. Now I want to pick another vowel. Go ahead.
3 out of 10.
3 out of 10. Check your second fraction. Did you say 3 out of 10? So then Did you multiply and get 12 out of 110? Which is, I agree, 6 out of 55. Guys, what if I wanted you to pick 3 vowels in a row? You'd have the first 4 out of 11, the second 3 out of 10. What would the third one be?
2 out of 9.
2 out of 9. Isn't that something? What would the fourth one be?
1 out of 8.
1 out of 8. What would the fifth one be?
0 out of
0, right. You can't pick 5 vowels in a row without replacing because there aren't 5. So anyway, that's how you do those. Aren't they kind of fun? So, if you are replacing the card, then they become independent events. Because if you're going to pick a letter out of mathematics, see what it is, and put it back in the deck, then the next time you go to pick, you haven't changed anything. So it is important to make sure that you're clear on, is this an independent event or a dependent event? Yeah.
If you do 4 out of 11, like the vowels, you get 1 out of 330.
Wow. So you have a 1 out of 330 chance of picking 4 vowels in a row? Very interesting. Okay, I'm going to give you a scenario. You tell me if it's independent or dependent. Flipping a coin.
Independent.
Independent. One flip has nothing to do with the next flip. When I pick your names out of this thingy. Dependent, right? If I have already picked 10 kids out, the likelihood of me picking you if I haven't called you yet is now a lot higher. Right? Yes. So if I'm taking these sticks out and I'm not putting them back in, that is a dependent event. Because now, at the first time, you have a 1 out of, what are there, 18 of you? You have a 1 out of 18 chance of me calling your name. But the second time, now you have a 1 out of 17 chance, 1 out of 16, 1 out of 15, until eventually I'm just going to call you, right? What about a locker combination? So, independent, right? You could have a locker combination that's like 10, 10, 10. The second number has nothing to do with the first number. So I could repeat them, I might not repeat them, who knows? What about the socks that you wear throughout the week?
Independent. Wait.
Dependent, right? So if you have a sock drawer, you open it up, you got 10 pairs of socks, you're probably not re-wearing your socks from day to day. So at the beginning of the week, you have 10 out of 10 to choose from, 9 out of, and then so on. It's going to decrease throughout the week. Let's do one more. I just got to think of one. How about, what'd you say? Oh, I thought you had an example for me. Ms. Muskie, you have any? Oh, sure. Yeah. Would the weather be independent or dependent?
No, it would be neither.
Well, does the weather today depend on the weather yesterday?
No.
So I'd call them independent.
That's what it is. Oh, by the way, I won't be here Monday, Tuesday, Wednesday, because I'm flying to Oregon on Saturday.
Take me with you. Actually, I'm kind of excited for I'm always excited for Thanksgiving, but I don't have to cook anything. I'm so glad. We found a place that's the whole everything, $100. The turkey, all the sides, and it's already cooked. I'm like, psh, yes, I will do that. I don't think so. If you're, because you gotta think, you gotta buy the turkey, the mashed potatoes, the sweet potatoes, the carrots, the green beans, and it comes with pumpkin pie. So if I was gonna buy all the ingredients to make these things, I think it would cost more than $100. Plus all the time to cook it, and I don't know what I'm doing. I have cookies that I make, and that's it. Everything else I'm no good at. Okay, so I think we're good with this. I think, unless I missed something. All right, yeah.